So today we are going to learn about controlling power or electricity or current. So today we are going to be doing that by constructing a simple circuit using an LED, a switch, and a battery. So today we are going to be using the coin cell 3-volt battery, the LED, and the switch. So we can either choose the push button or the slide switch, but today we are going to use the slide switch. So we have this. Now remember, the positive is usually associated with the red color and the negative is usually associated with the black color. Now this slide switch has 3 terminals. Okay, the first terminal to control what you'll be doing the component, then there's the common. So if I should connect the positive or the negative to this switch, I should connect to the common. Then the power should, if I want power to be generated from terminal 1, I connect to terminal 1. If I want power to be generated from terminal 2, I connect to terminal 2. So if the button is at this side, it means that the terminal 1 is closed. In circuit, when we say closed, it means it's on. And if I should push it this way, if the slide should come this way, then it means that terminal 2 is closed. That's the whole concept of the slide switch. So it just has 3 terminals, but for the LED it has 2 terminals: the cathode, which is your negative, and the anode, which is your positive. So I'm going to bring this switch here. I'm going to rotate this. Okay, now I can connect my positive to the anode and change the color to red. I can connect this negative to the common of the switch, and I change the color to black, making it negative for this. Then I connect this terminal 1 to the cathode, and I make it straight enough. So I've constructed a simple circuit. Now I'm going to run the simulation to get the concept. Now it's turned on, but you see this is giving us a warning. Current through the LED is 61.9 milliamperes, while recommended maximum is 20 milliamperes. The usable lifetime of the LED may be reduced. It means that we can't use this LED for long if we apply a current of approximately 62 milliamperes to it. So to do that, we usually add a resistor. Okay, now if you press the terminal, 2 will be on, making sure that this LED goes off. It opens terminal 1 but closes terminal 2. Now we are going to add the resistor. The resistor produces a resistance. So I'm going to delete this wire and delete it, and I'll bring a resistor here. Now, the magnitude or the value of your resistor will determine how bright it will be. So you shouldn't go more than 1 kilo ohms. Okay. Now let me change the color to red, and this one too, let's change it to red. Okay, so let's run the simulation. Let's turn it on. You see it's quite dim. You see that? Now let's get to know the magnitude of this resistor. It's 1 kilo ohms, which is too much. So I will recommend you use 220 ohms. 220 ohms, and let's run the simulation. Now it's bright, but maybe to you it might not be bright enough, so we can also alter the resistance. We can change to 20, just 20, or even let's go for 30 ohms, and let's run the simulation. Okay, it's bright enough, but we get this. So we are having 22.6 milliamperes, which is more than 20. So we can also change this to approximately 45 ohms. So 45 ohms. Okay, so we don't get any warning again. We don't get any warning again. So that's just for one LED. Now, if we want to give it terminal 2, we want to give it another LED. Let's see how we do that. So let's stop the simulation and add an additional LED. So I'm going to delete this wire and bring an additional LED here. So create an extension for the conductor and give it to the anode and make sure it's straight enough. Okay, it's straight enough. Now I can also connect the terminal 1 to this. Now I don't want it to be on it, so I'm going to pass it this way, this way, this way, and call it that for terminal 1. So I'll change the color to black, and I'm going to click this to make sure it is very okay. I connect terminal 2. Now okay, so we are done. So now let's run the simulation. Okay, so we get a warning because there's no resistor here. So now let's switch here. Okay, now the terminal 2 is closed, so we see the LED for terminal 2 on and terminal 1 off. If you slide it this way, terminal 1 is on, terminal 2 is off. Now we are going to add a resistor to terminal 1's LED. So I'm going to delete this LED, this wire. Let's stop the simulation, and or I can also change the color. Now every LED has the maximum current it takes. So violet is the highest, followed by the color blue. Okay, so I can change this and it will still get a warning though. Okay, we don't have a warning, I think so. I think blue has the highest in TinkerCad, but violet is the highest in the world, I think. So when it's on, it's quite dim, right? Because in series connection, current is the same. So the current for this and the current for this is being shared. So I think this parallel. So current is being shared. That's why we get this. So you can see the blue, but it's quite dim. If I should stop the simulation, you see it's going off. If I should run it, it's quite dim. It's quite dim. Okay, that's all for today. Thank you.